Hello, and welcome to the fourth lesson of the Big Data and Hadoop Administrator course, offered by Simplilearn. In this lesson, we will discuss Hadoop configuration and daemon logs. After completing this lesson, you will be able to list and describe the files that control Hadoop configuration, explain how to manage Hadoop configuration with a Cloudera manager, locate configuration files, and make changes. Explain how to deal with stale configurations. Explain the RPC and HTTP default address and ports used by Hadoop daemons. Locate log files generated on hosts. Filter information in log files. Explain how to use logs to browse information and diagnose issues. Hadoop configuration. You have learned previously about Apache Hadoop and Cloudera cluster setup. You have also learned about working with a cluster manually, as well as through the admin console. In this lesson, we will discuss how to configure a Hadoop cluster, configurations that control the running of a Hadoop cluster and its components, and how to alter configuration file contents. We will cover the properties of default addresses and ports of Hadoop daemons. We will also look into obtaining diagnostic information from log files. In order for Hadoop to run in a selected mode on a cluster, it is important to accurately specify the configuration parameters. Hadoop's cluster configuration can be set up in the following files. Hadoop env.sh contains important environment variables required for Hadoop to run. Core site.xml is a file that contains configuration settings for the Hadoop core, such as I/O settings common to HDFS, MapReduce, and Yarn, the HDFS path, the name node location, and so on. MapRedSite.xml contains configuration settings for MapReduce daemons, the location of job history server, processing framework, processing limitations, and so on. HDFSSite.xml contains configuration settings for HDFS daemons, including the location the daemons store data, their ports, replication factors for blocks, schedulers for resource management, and so on. MapRedEnv.sh contains the environment variables used to run MapReduce jobs. Note that these settings override the variable settings given in Hadoop env.sh. Yarn env.sh contains environment variables for Yarn processing. These settings override the variable settings given in Hadoop env.sh. Yarn site.xml contains configuration settings for Yarn daemons, including their classes, schedulers, commissioning and decommissioning properties, and so on. Hadoop metrics2.properties contains properties for controlling how metrics are gathered and published in Hadoop. Log4j.properties contains properties for system log files, name node audit log, task log for task JVM process, and so on. Hadoop policy.xml contains the configuration settings for access control list or ACLs when running Hadoop in a secure mode. Slaves contains a list of machines that run data nodes and node managers on them. Hadoop configuration files are found in /etc/Hadoop, /opt/Cloudera/parcels when using CDH. A specific directory chosen by the admin when using Apache Hadoop core distribution. The configuration directory can be relocated to another part of the file system, external to Hadoop's installation path. This makes management and upgrades easier. If the configuration directory is relocated, Hadoop daemons will have to be started with the --config option, or with the related environment variable that specifies the location of the directory in file system. Note that Hadoop does not have a single global location for configuration information. Instead, Each node in the cluster has its own set of updated configuration files for the daemons or roles running on those nodes. The admins have to ensure that the configuration files are coordinated. Let's now discuss how to manage cluster configurations. Cluster management tools are very effective at managing configurations. Cloudera Manager and Ambari are two tools that are popular for their capabilities of propagating changes across the cluster. Let's now list some of the advantages of using cluster management tools. Cluster management tools enable automated wizards to quickly deploy a cluster with intelligent default settings and configurations based on the system. Ensure consistency across environments with portable cluster configuration templates. Provide a centralized interface to easily tune configurations and resourcing parameters. Recommend pre- and post alerts when changes in configuration settings are required, and if the set values are optimum. Help in keeping all machines in sync and ensure that the machines are performing regular maintenance tasks, such as patching security holes and updating system packages. Hadoop is designed to support a single set of configuration files for all master and slave machines. However, some clusters do not support this approach. One scenario where different configurations are required is when a cluster is expanded and the new machines that are added differ in their hardware specifications from the existing machines. To manage such configurations, external tools such as Chef, Puppet, CF Engine, Salt, Ansible, and so on are available. Let's now revise some important terminologies that will help in understanding the forthcoming topics in this lesson. A service is a category of managed functionality in Cloudera Manager. It may or may not be distributed. In traditional environments, multiple services may be run on one host. In distributed systems, the services may run on many hosts. Some examples are HDFS, MapReduce, Yarn, Scoop, and Hive. A service instance is an instance of a service running on a cluster that spans many role instances. Examples are HDFS and Yarn. Roles are daemons or processes that can take care of a service. Roles can be called categories of functionality within a service. For example, the HDFS service has roles such as name node, data nodes, and secondary name node. A role instance is an instance of a role running on a host. It typically maps to a Unix process. For example, namenode-1 and namenode-2, in case of high availability, are two instances on two machines. A role group is a set of configuration properties for a set of role instances. Let's now discuss how to manage Hadoop configurations with Cloudera Manager. First, Cloudera Manager has configurations related to its own administrative operations. These have to be set up. Hosts include configurations related to monitoring, software management, and resource management. Cloudera Manager defines and manages configurations at different levels. Let's now discuss these levels. The first level is the @service level. Configurations for services are defined at this level. These are applicable for overall service. An example is the default replication factor of HDFS service, the property name of which is dfs.replication. The next level is @role group level. All configurations applicable to member roles are defined at this level. An example is the handler count of the data node, the property name of which is dfs.datanode.handler.count. The value of this can be set differently for different groups of data nodes. For example, data nodes running on more capable hardware may have more handlers. The next level is @role instance level. Configurations applicable to the role instances are defined at this level. These configurations may also override any configurations inherited from the role groups to which the role instances belong. Therefore, These configurations should be set carefully, as discrepancies may arise within the role group. Let's now understand how the Cloudera Manager helps to handle configurations at different levels. You have learned that configurations can be set at service level or role instance level. YARN is an example of service level configuration, and Resource Manager is an example of role instance configuration. An individual role inherits configurations set at the service level. If configurations were set at the role level, these would override the ones inherited from the service level. Cloudera Manager allows configurations to be assigned to a group of role instances via role groups. Members of the role groups then inherit these configurations. Thus, Cloudera Manager helps to easily manage configurations of role subsets, maintain different configurations for testing and managing of shared clusters for a variety of workloads, independently control processes, since all the processes have separate execution and configuration environments. Note that service-related role instances obtain their configurations from a private per-process directory found under /var/run/cloudera-scm-agent /process/unique-process-name. Configurations are specified in resources. A resource contains a set of name and value pairs in the form of XML data. For example, consider the file hdfs file.xml. The name dfs.replication and value 3 is specified under the property tag, as you can observe in the code shown on the screen. Let's now look at how configuration is handled in Cloudera Cluster and in core Apache Hadoop. In Cloudera Cluster, the Cluster Setup Wizard downloads Hadoop and related parcels and sets up some services by default. It assigns roles to hosts based on an internal check of node configuration. However, the admin can also configure services and assign or change role assignment to hosts. It also auto-generates and populates the configuration files based on the role placement and allows the admin to change, update, delete, or disable properties. In contrast, in the core Apache Hadoop cluster, the admin has to manually download the tarball for Hadoop or Hadoop components, untar it, and edit the configuration files manually and differently on different hosts. This was demonstrated in the Apache Hadoop cluster setup and Cloudera distribution for Hadoop, or CDH setup demo. Let's now look at the files that set up the configurations. Firstly, we will look at setting up environment variables. Files that include these are Hadoop env.sh, mapred env.sh for MapReduce, yarn env.sh for YARN. In Hadoop env.sh, set up the following configurations. In Java_home, specify the path to the Java implementation that the cluster has to use. In Hadoop_heap size, define the memory heap size to be used by the name node. Similarly, heap size can be set for individual daemons on respective nodes. By default, Hadoop allocates 1 GB of memory to each daemon. An important point is that if heap size is not correctly set, or is less than optimum, the HDFS service is impacted and shows an alert to tune the heap size value. In Apache Hadoop, the wrong setting of the heap size affects the name node. Note that in yarn env.sh, yarn_resource manager _heap size is used to define the heap size for resource manager. In Hadoop_log_dir, specify the path where the system log files created by Hadoop are stored. Default value for this variable is $Hadoop_home/logs. It is recommended that you specify a location other than the Hadoop installation path. Let's look at some other typical configuration files in detail. In core site.xml, you can specify the configuration for the master or name node for the HDFS. To run HDFS, at least one machine should be designated as the master. With the property fs.defaultfs, you can define the HDFS file system path and specify the location of the name node as shown on the screen. You can also specify the port that the name node will listen to for a remote procedure call or RPC. Note that if no port is specified, the port 8020 is used by default. In hdfssite.xml, you can specify the configuration for the storage directories where name node and data node will store data. With the properties dfs.namenode.name.dir and dfs.datanode.data.dir, you can specify the storage directories for the name node and the data node as shown on the screen. Note that if the path is not specified, the default location /tmp is used. It is recommended that you have metadata or stored data in multiple locations, such as multiple disks or a remote disk, using an FS mechanism. The advantages of storing data in multiple locations include fault tolerance, better read-write I/O, and so on. The property dfs.namenode.checkpoint.dir should contain the path for the secondary name node, which does the checkpointing and stores a copy of name node's metadata. In yarn-site.xml, you can specify the machine that is designated as the master for the processing layer, that is, the resource manager to run. With the property yarn.resourcemanager.hostname, you can specify the host name where the resource manager will run. And with yarn.resourcemanager.address, you can specify the host name and port as shown on the screen. With the property yarn.resourcemanager.local-dirs, you can specify the location of local temporary storage for YARN containers and temporary intermediate data that is written when MapReduce jobs run. YARN relies on MapReduce shuffle handlers to serve map outputs to reduce tasks because it does not have task trackers like MapReduce. Shuffle handlers are long-running auxiliary services running in node managers. YARN is a general-purpose service, and the MapReduce shuffle handlers need to be enabled explicitly in yarn site.xml. To do this, you can set the property yarn.nodemanager.aux-services to MapReduce_shuffle. You can specify the amount of physical memory in megabytes that may be allocated to containers being run by the node manager in yarn.nodemanager.resource.memory-mb. You can specify the number of CPU cores that may be allocated to containers being run by the node manager in yarn.nodemanager.resource.cpu-v-cores. There are many more properties which can be set up in configuration files if required. If any changes are made to the cluster, it leads to stale configurations. This requires a restart of specific roles, services, or the cluster itself. You can view the old settings and the changes made on the stale configuration page in CDH. You can view entries of all affected attributes on this page. To view the stale configurations on the home page or on the service status page, click the indicator icon next to the service. On the stale configurations page, you can view the following categories of attributes. Environment. This category shows environment variables set for the role. Files. This category shows configuration files used by the role. Process user and group. This category represents user and group for the role. Every role type has a configuration to specify the user or group for the process. Any configuration change to a user or groups leads to stale configuration, which can be viewed in this category. System resources. This category shows system resources allocated for roles, such as ports, directories, limits, and so on. Changes made to ports can be viewed in this category. Client configs metadata. This category represents client configurations. Stale configurations can be filtered based on attributes, service, or roles. Let's now look at how to fix stale configurations. The following actions will help fix stale configurations. Restarting the service. Restarting the role or role group. Restarting the cluster or set of prompted services. Refreshing stale services. Restarting Cloudera Management Service. Note that in Apache Hadoop cluster, any configuration changes made requires restart of related daemons and master daemons. Looking into logs and filtering information. In this demo, you will understand how to look into the logs and filter information in our Cloudera cluster. You can look into logs by clicking on Diagnostics and then clicking on Logs. Once you click on Logs, you will find a search button. When you click the search button, it will show you all the logs in our Cloudera cluster. The information on screen is classified into 5 columns. First is the host, which shows the details of machines. Next is the log level, followed by time. Then there is source, which provides details from where the information is taken. And finally, the messages. To view the complete log details for a machine, click on View Log File. Here you can find the host details, role, and the file location, which can be viewed using the terminal in a machine. You can always download the complete log file using the button on the top right, Download Full Log. You can also filter the log based on time duration. In Log Details on screen, you can find warning messages, error messages, and some information about the machines from where the information is extracted. If you type error in the search bar and click on Search, you can find all the error-related messages. Similarly, if you type name node in the search bar, you can find all the messages which contain name node in it. When you click on Select Sources, you can have all sources ticked. Or you can also select the sources based on our requirement. Under Cluster 1, you have all the tools of Hadoop. Under Cloudera Management Services, there are all the types of monitor services, and under Cloudera Manager, there are agent or server. If you require only the information related to processing, you can select Yarn and click on Search. This gives us all the information related to the components of Yarn. You can also use Minimum Log Level and select the type of information you require. Here, there are the following: Fatal, Error, Warn, Info, Debug, and Trace. If you select Warn and click on All Sources, Then you can find the list of all warnings. There is also an option called Additional Settings, and when you click it, you can change the number of results per page and search timeout. In Diagnostics, there is Events tab, which displays all the events that have happened in the cluster. If you require more information about a particular event, you can click on Expand and then click on the URL to find more information about that event. There is an option called View, which should be opened in a public DNS to view the details of that event. You can add a filter or search recent events that took place using the Recent option. In Diagnostics, there is a tab called Server Log, which will display the Cloudera Manager server log details. When you work on logs, click on Logs in Diagnostics and click on any log file. This will display an option, File, which is a link for error location. Log files are of two types. They are .out and .log. .log is rotated using log4j properties. Using the link, you can also look into the log by entering it on the terminal of the respective machine. In this demo, you have seen how to find information using logs. Let's now look at Hadoop daemons and roles. Hadoop daemons run both an RPC server for communication between daemons and an HTTP server to provide web pages. To configure the servers, the network address and port number are set up. The properties for setting up a server's RPC and HTTP address determine the network interface that the server will bind to and are used by clients or other machines in the cluster to connect to the server. In addition to the RPC and HTTP servers, data nodes run a TCP/IP server for block transfers. Let's now see the RPC server properties. Observe the table on the screen. It lists the RPC server properties and their descriptions. It also shows default ports used by the properties. Now, observe the table on the screen. It lists the HTTP server properties and their descriptions. It also shows default ports used by the properties. Another property is dfs.datanode.dns.interface. It is used to specify which network interfaces are used by the data nodes as their IP addresses to connect with RPC and HTTP servers. If no specification is made, the default network interface is specified. Working with logs. All hosts generate logs. Logs mostly include role-related information for normal operations, standard out and standard error files, internal diagnostic information. Let's now see how we can view log information. To view the log information for Hadoop services, navigate to Diagnostics and then click Logs in the Admin console. To view all the logs for all roles, navigate to Diagnostics and then Logs and click Search. You can also search based on a specific keyword, severity, or specific error. Log results are displayed as a list with the following columns. Host. This column displays the host where the log entry appeared. Log level. This column displays the log level or severity associated with this log entry. Time. This column displays the date and time this log entry was created. Source. This column displays the class that generated the message. Message. This column shows the message portion of the log entry. The View Log File option displays the log page with all the entries. It shows the selected message as well as 100 preceding and following messages. You can filter information from logs based on the following parameters. Time range selector, or duration link. This parameter is useful to view information logged in during a specified time range or duration. For example, messages in the past 30 minutes, 1 hour, 2 hours, and so on. Search phrase. This parameter enables you to enter a case-sensitive string and search for information that matches the string. Select sources. All services and roles in a cluster are selected by default. By using this parameter, you can select specified services and associated roles and filter information based on the selections made. Hosts. You can view information about specific hosts or about all hosts. If you type a partial name, Cloudera Manager shows a list of available hosts that match the name, and you can select the required ones. Log level and severity of messages. You can filter information based on severity of messages, such as warn, fatal, error, debug, and so on. Search, timeout, and results per page. These parameters allow you to control timeout of search option and the number of results that should be displayed per page. Note that if required, you can download the full log from the Logs page. On the Logs page, you can click Change and change the hosts or roles to retrieve information specific to the selection. Screen 25. Log information in CDH. Let's now look at the locations where you can find log information in CDH. To view logs pertaining to a specific role running on a host or services running on a cluster, click the View Log link and open the Logs page. Logs can also be seen from Linux terminal in /var/logpath. For log information about Cloudera SCM server and agents, you can either view it from the admin console on the user interface or from the terminals. From the admin console, first click Diagnostic, then Logs, and then click Select Sources. Clear all the options. Select Cloudera Manager. Select the agent or server based on the host, and then click Search. To view the Cloudera Manager server log from the admin console, click Diagnostics, then Logs, and then click Server Log. From the admin console, to view the Cloudera Manager agent log, first click Hosts and select the required host. Next, click Details and then click Agent Log. To view log information from the terminal, type the paths at the terminal as shown on the screen. Information about Cloudera SCM server, Cloudera SCM agent, Cloudera SCM event, and Cloudera SCM installer can be found in these locations. Let's now look at finding log information in Apache Hadoop cluster. In the Apache Hadoop cluster, the environment variable set in Hadoop env.sh defines the path where logs for daemons will be stored. The default path is $hadoop_home/logs. Observe the screen to know how the path is specified. Roles in CDH are called daemons in Apache Hadoop. All daemons generate logs on their respective hosts. The logs are placed in the logs directory. There are two types of log files that are created in the logs directory. Files with the extension .out. These contain logs that are written when daemons are starting up. Files with the extension .log. These contain all the messages, including the startup daemon messages, that are sent to .out files. The naming convention followed for the .log files is shown on the screen. The name of the user running Hadoop is followed by the daemon name and then the host name. Daily rotation of log files is determined by the property set up in the log4j file Rotation means that a new log file is created to capture information, and this will replace the current one. The log4j file can be found by navigating to etc/hadoop/conf/log4j.properties, or by navigating to the Hadoop location and then navigating to conf and log4j.properties. Let's now note some more important information about logs. Job configuration XML logs are created by the processing master, job tracker, or resource manager. These logs are .xml files generated for every job. They are not rotated and can be viewed by navigating to /var/log/Hadoop folder or /var/log/Hadoop/history folder. The convention followed to construct Hadoop file names is job, followed by the job ID, and then conf. Observe the screen for the convention followed by an example. The convention followed for the Hadoop history file names is the host name, followed by the number of milliseconds that elapsed since the Unix epoch time when the job tracker daemon was started, followed by the job ID. Observe the screen for the convention followed by an example. The standard error logs are created by each task tracker and contain information about standard errors captured when a task attempt is run. These logs can be used for debugging. The standard error log file is created with a naming convention that includes the job ID and the attempt ID. Observe the screen to view the complete path to access an error log. Working with configurations in Cloudera cluster and fixing stale configurations. This demo will show you how to configure in a running cluster. Some of the services had been installed previously. Hence, in order to change any configuration, you will have to use only the Configuration tab. Once the configuration is completed, you will be asked to restart the cluster for the changes to be reflected. First, click on HDFS. Then click on the Configuration tab. This shows the configuration of HDFS based on different scopes. To check a specific configuration, click on the respective scope. In this case, select Name Node, and under Category, select Replication. You will see only one replication-related configuration. Under Scope, select HDFS. As you can see, the replication property is set to 3. You can overwrite the replication factor by using the setrep command. In this case, change the replication factor to 4 and click on Save Changes. Go back to the cluster, where you can find all the details of all the services that need to be restarted, along with the services that have stale configuration. Restart the cluster, or restart the services of the cluster individually. To restart each service, go to Actions and click on Restart. You can also restart the services using the Status column on the left. First, restart Yarn. When you click on Yarn, it will take you to the Stale Configuration page. Stale Configuration has 2 filters, which are File, which displays the location where the changes will be carried out, and Services. In HDFS and Yarn, the value is changed from 3 to 4. The second filter is Services, which displays the services that are affected due to the change in configuration. Click on Restart Stale Services, which will ensure that you start the services using rolling restart. As mentioned earlier, an alternate is to go to Actions and click on Restart, then click on Cluster Restart. If you change the configuration of a particular service, you can only restart that service or restart other services that depend on the service that has been configured. As you can see, the services are getting restarted one after the other. Meanwhile, take a look at the warning messages by clicking on the icon beside each service. The first message indicates the memory in the respective machine is overcommitted, giving you the required clarification to resolve the issue. You can ignore the issues by clicking on Suppress, and in the dialog box enable Suppress for all hosts, and also add a comment. Then click on Confirm. Similarly, under Hive Server, the issue is about Spark Executor cores. You can click on the message to go to the page where the issue exists. Under Spark Executor cores, you will see the value as 2. Change this to 4. Once changed, you can also add the reason for change and click on Save Changes. Restart the service if required. Now check the warning of Hue configuration. If it is HDFS Web Interface Role, click on the warning. Clicking on the warning will take you to the place where the error took place. If the error is HTTPFS role is recommended for web interface if HDFS is HA or federated, select Name Node IP-10-0-0-0-148 under HDFS Web Interface Role. Under Suppress Parameter Validation HDFS Web Interface Role, enable the Hue Service-Wide option, then save changes and go back to the cluster. Click on HDFS Service, and under Action, click on Deploy Client Configuration, and select Deploy Client Configuration. This will enable you to restart any stale or outdated configuration that was affected due to recent changes. Then go back to the cluster. Refresh the page, and if you still find errors beside the services, click on the stale configuration page. Uncheck Rolling Restart. Enable Redeploy Client Configuration, and finally click on Restart Now. When restarting is complete, click Finish. You now can see the stale configuration errors have been fixed. This ends the demo, where you learned how to work on configuration files and fix stale configurations in Cloudera Cluster. Following is the quiz section to check your understanding of the lesson. Select the correct answer and click Submit to view the feedback.